Hey everyone, welcome back. Let's continue on with Chapter 8, Section 3, Inverse Trig Ratios. We've already done trig ratios, so inverse trig ratios are going to help us find missing angles, which leads us to our I will statement for today. I will solve for missing angles using inverse trig ratios. So right now, make sure you have your comp book in front of you, that you have your title written here on your page and in your TOC, your table of contents, and that you have your I will written for the day. Okay? All right. Let's continue on. First part is just a quick review, okay, just to make sure that we know what we're doing. You can pause here and go ahead and get all of this written down and then come back and join me. All right, let's keep on. Sine of A, remember this gives us which angle is our reference angle. So we have sine of A, which is opposite over hypotenuse, BC over AC. We have cosine of A, which is our adjacent over hypotenuse, which is AB over AC. And we have tangent of A, or of this angle, which is the opposite over the adjacent, or BC over AB. Okay, when we use our inverse trig ratios, it helps us to find our angles, and we will continue to use the ratios that go with them, all right? So let's look at sine of A first. Let's find this angle first. Sine of A, remember, was 4 opposite over hypotenuse, 4 over 5. You're going to write it like this, inverse sine of 4 over 5. Now let me show you on our calculator. You do, and let me show you the buttons. You'll push second and the sign button right here. See the SIN with the -1 right there? Second sign, and then type in your ratio, okay, and enter. All right, it gives us 53.13. All right, you can round that to the nearest degree if that's what they ask you for, or just leave it at the hundredths place. All right, now let's try and find it with the cosine. Okay, so cosine of A is 3 over 5. When I put it into my calculator, okay, sorry, got to hide these things first. Cosine, let's go back. Remember, we got to do the inverse cosine of 3 over 5. And what do we get? Exactly the same thing. And I bet you know that if we do tangent, that it's going to give us exactly the same thing. Well, let's try it. We have inverse tan of 4 divided by 3. And that gives us exactly the same number. So something tells me that angle A is going to be 53 degrees. What do you think? All right. Let's keep going. Okay, let's see how much you've already learned. Here it says find the angles. All right, so on this, you can go ahead, and if you want to, you can go ahead and draw both of our diagrams for today. These are our 2 examples for today. So you can pause me here and go ahead and draw these. All right, are you back? You ready? Okay, let's see if we can find some angles here. I think the first one we want to find is angle A of this one, okay? So let's see. If we're doing A is our theta, or our reference angle, then tangent of A is the opposite of that angle over the adjacent, so 15 over 8. So when we put in our calculator inverse tan of 15 over 8, we get angle A is approximately 61.93 degrees or 62 degrees. Okay, very good. And I challenge you now on your own to find the sine and cosine if you like. What I'm going to do now is continue on with this angle though, or this diagram. And I'm going to try and find, I want to find X, but I don't have any angles right now to use. Okay, now, yes, I could use Pythagorean theorem. You're right. But what I want to do is be able to find it using my trig ratios. So let's find an angle first. I can either do cosine to find an angle, okay, because I have adjacent over hypotenuse to C, or I could use sine of B because I have the opposite over the hypotenuse for angle B. So that's the one I've chosen here, is sine of B equals 10 over 15, which means I don't have an angle, so I've got to use inverse sine of 10 over 15. I put it in my calculator by just pushing inverse sine. I push second sine, or the sin looking button there, and I believe it was 10 over 15. All right, close my parentheses, and I get 41.81. Okay, so 41.81, or about 42 degrees. Now when I now have this angle, And to this angle, I have an adjacent over hypotenuse. The one I need is the adjacent. The one I have is the hypotenuse, okay? So I'm going to move this over so you can see it. So I do tangent of 42 degrees equals opposite. I don't need the hypotenuse. Y'all could have told me that. I'm going to use the opposite over the adjacent if I use tangent. Or what would I have used if I had used adjacent over hypotenuse? Cosine, exactly. So we'll do that in a minute. But let's do tangent of 42 equals opposite, which is 10, over adjacent, which is x. This is just like a regular, Alright, sorry about that. Just a little interruption. Okay, so we had tangent of 42 degrees equal opposite over adjacent. This is just like a regular algebra problem now. We're going to multiply tangent of 42 times x equals 10. And remember, if this was a regular, the calculator treats this as one number. So it's going to be 10 divided by tangent of 42. And let me show you what I mean. 10 divided by, parentheses, tangent 42 equals 11.11, okay, 11.106 or 0.11, and that is what we get for x on that one. Well, let's go ahead and do what we said a second ago. Let's try using cosine, okay, of that 42 degrees that we had. That's going to be, what is that? Adjacent over hypotenuse, right? So we have x over 15. You see it? So when we cross multiply, we write it like this, cosine of 42 times 15. Okay, let me see if I can get it where you can see it. There you go. You're going to put in your calculator cosine, I'm going to put it in parentheses, cosine of 42, close parentheses, times, what was it, 15? 15. Okay? So notice how we get about the same thing. If I round both of them, it's to the 0.11 there, 0.15 here. So very, very close. Sometimes your trig ratios will be off just a decimal or so, but usually they are right on. Okay? All right, this wraps up our notes for today. I hope you have a wonderful evening. I do challenge you to go ahead and find the cosine and sine of this one, and we can check it in class tomorrow. If you have any questions, please write them down or email them to me or Miss Scott, and we will be sure to answer them tomorrow in class or even this evening over email. Have a great, and we will see you tomorrow.